Alrighty. Welcome, everyone. My name is Mike Patria. I'm with Curtin Maritime. We are a dredging and marine transportation contractor. My job title is Director of Depth, which is kind of a long-winded acronym here, but it's Dredge, Engineering, Production, Technology, and Hydrography. And today I'm going to be talking about some survey data for the dredge crew on mechanical dredges, so a sonar on a dredge. But I want to emphasize that this is going to be data that's going to be used for the dredge crew so they can make the most informed decisions. This has been a growing topic. I mean, just this conference, there's been 2 live demo streams. Jerry's going to be doing a seminar tomorrow, I believe, and then have this case study. And it's not necessarily a new concept. People have been putting sonars on dredges for a while, but especially with the multi-beam, that's becoming new. But it's definitely growing in interest. This is our dredge, the DB Avalon here, and I want to take note of the turbidity plume there out in front of the bucket because that's going to cause some issues with the sonar, but we'll get to that further down the road. I'm going to be focusing on the mechanical dredges. A lot of it will overlap with hopper and cutter suction dredges, but the one difficulty with a mechanical dredge is it doesn't move, so you can't get the coverage. The hopper dredge, it's self-propelled, so it's just basically a survey boat with the sonar on it. And then a cutter has a spud in the stern, and as it's rotating, you can get that coverage, but run into a problem with a mechanical dredge is that it doesn't really move all that often. So we're going to talk about how to overcome that. So what I set out to do is trying to solve 2 issues that we were having, just trying to maximize our production and save money. The first one was increasing the accuracy to our dredge depth, for a payable volume. We don't want to be under digging, we don't want to be over digging. And the issue is with our survey boat, we can only survey once, maybe twice a day. And let's say we move to a new area with different material, or we change buckets, or we're digging deeper, or whatever changes happens over the night. They're digging like that for 24 hours. And they don't have any feedback on what they're doing. So you could have just overdug all night, and then you're not getting paid for that material. So what we need to do is, how can we get more frequent feedback to the operators on their dig patterns all throughout the night and whenever there's not a survey boat. And then the second thing we were trying to solve for was minimizing rework digging or shoaling digging, cleanup digging. And the problem with that is wastes a lot of money when you have to remobilize a dredge to an area that you already dug just to pick up a few high spots. So to solve that, we want to be able to display sonar data or survey data of the bathymetry compared to the dredge template in real time to the operators. And what I wanted to emphasize is what we weren't really trying to solve was to eliminate the need for our survey boat. I still think that we need our survey boat to survey other areas that we're not digging to get before dredge surveys or investigational surveys. If we're bringing support equipment to a different area, want to see if it's deep enough to do that, or there's always other reasons to have a survey boat. So we weren't going in with the expectation of eliminating a need for a survey boat. So the solution is a dredge-mounted sonar, and this might look familiar if you were sitting in on the demo earlier. Basically, how could we integrate a sonar into the dredge positioning software in order for the operators to make good decisions? So I worked with 3 different companies, demoed all 3 on our dredge, the DB Avalon. We worked with Kongsberg, and they work with SPE for their software side of things. And they had the dual axis sonar, and this is actually a single beam. Inside that dome up there is it's an oil-filled dome, and it's a single beam transducer that's within there, but it actually rotates to make a point cloud to try to get as close to a multi-beam as possible. And there's some pros and cons to that, and we'll discuss a little later. Then we worked with Norbit's system, the wing head, and they had their rotator on there. So yeah, the reason for the rotator in the single beam and in these multi-beam systems is since the barge is stationary, we need to be able to rotate that swath in order to get the coverage of survey data. So that's why you'll see in that single beam has the built-in rotation, the Norbit has it, and then also the R2 Sonic, we work with Telestra, and we demoing the Sonic 2020, and they had the Sidus rotator. So I'm going to briefly go over just the different hardware packages for each. I'd advise you, if you're interested in any of these, to talk to the manufacturer yourself and get more details, but I'll just do a brief overview. So this is the single beam package. You can see we just had, the middle picture is what our setup was, and that was another setup from another installation that Kongsberg did. But yeah, the sonar is just on a pole underwater, and then it's not shown there, but there was a motion sensor on that pole as well. This was just a temporary setup. We had it set up for just a couple of weeks, so we didn't make it a real rigid pole. So it's wobbling down under there, and it's going down 15 feet. So we needed to have a motion sensor on the sonar itself, because it would be swinging independently of the dredge. They also had another IMU on the barge to track barge motion, and then a PLC as well that's connected into our dredge network that fed the GNSS and other sensors from our dredge. This is their software called MARPO that SPE created. You can see in the top left there, it almost looks, that's the sonar data, and it almost looks like multi-beam data, but that's all from a single beam. As it's scanning, the longer you leave it, the more data it's going to generate. So, which can cause a problem on a dredge, because sometimes you don't have all that time to just sit there and scan for 20 minutes, 30 minutes. The density, you can do a 5-minute scan or a 30-second scan, but you're not going to get that dense of data. So it's really just what your application is and what's important to you. And this is kind of a full suite of it's a complete dredge software package. So they have the plan view there. You can see the outline of the dredge. They have the 3D view, and then that profile view. And in the 3D view and the plan view, you can alternate between what the sonar depths are showing, the colored contours, or what the bucket thinks it's digging. So just with the encoders on the winch for the bucket, the maximum depth it's going to, it will draw that contour. So you can toggle between what the bucket thinks it's digging or the sonar data. And you can see that in the profile there. So that pink is where the bucket thought it was, and then the blue was actually the sonar data. So you can see that there is a difference. And that could be caused from spillage or inaccurate sensors or what have you. And that red line is just the design template. This is the Norbit GUI, the interface, and this might look familiar. It's if you use a Norbit system, this is, or really a lot of the systems, the R2 Sonic and Rezon and all that, all look very similar. And you control it the same way you would on the survey boat. You can set gates. You could, you see the alarms up top that tell you if, for instance, if attitude is not correct, precise, or you don't have RTK solution. So you just control that the same way. And Norbit has their own system called Dredge. And so on the left-hand side of the screen is the Sonar interface, and the right-hand side is their Dredge system. And then, which is broken into two sections on the right. So the left-hand side of that with the red and green, that's going to be your sonar depths to the dredge prism. So that face, we call it in dredging, but the distance that we have to dig down. And on the right-hand side is just straight bathymetry, whatever the depths are. And you can move that slider in the middle if you just wanted to see one side or the other. The red rectangle, it might be hard to see, but the red rectangle is the dredge. The red dot is the bucket. And then that V shape, that wedge with the yellow lines, that's where the rotator is currently pointing. And what Norbit does is they physically rotate with the rotator, the sonar, and then they beam steer within that wedge, and then move it to the next location, and then beam steer in order to get that full painted picture there. And then it's really hard to see, but going off the front of the dredge there is some green lines, and that's where you set the limits to how far you want the whole rotation of the sonar to be. So there would be 180. We were just scanning out in front of the dredge. One nice thing that the Dredge system is, it's a web app. So you just open up a browser. You can do it on your phone, a tablet, any computer that's on the network with the dredge. And not only could you view this data, but you can control it too. You can start and stop the scan. You can open up the wedge, the scan limits. So I thought that was a really cool feature. And then they also had a sounding quality filter. So, if there's turbidity in the water and it's not getting a good return, it will eliminate those pings and it won't plot it on the picture there. So that was a really good, nice feature. And this Norbit system also works in Dredge Pack as well. So if you like the features of Dredge Pack, you can utilize this Norbit system in Dredge Pack or Dredge. So either way. So with the Norbit system, they, in order to get that red dot on the screen to show where the bucket is, you really need a GGA input and NEMA GGA input from your GPS that would be at the boom tip, but our dredge didn't have that. Our dredge has our GNS antennas on the barge, and then we use the crane slew sensors and boom angle sensors in order to calculate the bucket position. So we have to figure out a way, how do we get that GGA string into the topside unit of the Norbit. So in order to do that, Dredge Pack has a good feature in HiPack hardware. They have a driver called NEMIA output. And so we just went to our bucket mobile, and you can see in the bottom right here, and just exported that to a serial server. If you guys are familiar with that, it's just a serial on one end and an Ethernet on another end. So since the computer was really far away from where the topside unit was, we just used our existing dredge network because we couldn't run a serial cable 200 feet away. So we were able to plug the serial straight into the topside unit, export the GGA string to on the network on the Ethernet cable, and plug that straight into the topside. So that's how we were able to solve that. This is now the R2 Sonic system that Telestra helped us out with. Very similar to the Norbit system. It has the Sidus rotator, the sonar. It has IMU at the head, which is their integrated, what they call the integrated system, and the sound velocity probe as well. On the right-hand side is the topside unit for the R2 Sonic, and then up top, that black box is what controls the Sidus rotator. And for the R2 Sonic, we did use Dredge pack. The top right is the normal sonic control. If you're familiar with R2 Sonic, it looks very similar to the Norbit system as well. That's the interface for controlling the sonar itself. And then the rest of it is basically what you see if you're doing high sweep. It's all the same windows, but it's in Dredge pack. And then on the left-hand side is how we control the Sidus rotator, and Jerry will be going over that a little bit more in depth. He was the one that created that in tomorrow's presentation. But basically, the red lines there, you can control the rotation limits, and then that black arrow will show you exactly where the sonar currently is, and have the stop and start buttons up top. We were scratching our heads for a little while on how to mount it at first, because we want to angle it in such a way that if you had it pointed straight down, it would just be rotating and making a small circle, but you want to really be able to angle it and then fan it out in front of us. And you want to make sure that the projector on the sonar head is facing the right way, so it's fanning out like this rather than like that. So it's getting a full swath of the area, and I'll show you in this next slide here. So on the bottom left-hand side, it was, if it was to just be scanning without without that angle. And then even if you do have that right, we found out another issue was in R2 Sonic setup, they have roll stabilization, which is a great feature when you're on your survey boat. And it basically, if you see in the top right, it's showing the sonar angled, but it's beam steering down. And we don't want that. We want it to be able to point out, so it's getting a bigger swath. So, the maximum we can get with the roll stabilization on was only 50 feet. But once we turn that off, and it was actually using the true angle, not trying to beam steer, we can get out to 110 foot in front of the dredge, which is, we want to try to maximize how much area we can cover since the barge isn't actually moving. And you can see that the SBG unit, that's the IMU, you can see the roll had a 24-degree pitch, and that's coming from and that's coming from just the hard angle of the mount that's attached to the Sidus. If you're going to implement this on your dredge, there are some mounting considerations for us, our scow tie-ups. So our scow barges, we tie them on both sides of the dredge, so automatically we can't put our sonar on either side of the dredge. So that leaves just the bow and the stern. And the stern is sort of far away from the digging tool, so you're not getting the most up-to-date information. By the time the sonar was to reach where you had just dug, it could be a half hour, an hour, just depending on how fast you're moving. The stability of the pole, we talked about that a little bit earlier, but if you have a wobbly pole, you're going to want to have an integrated, an IMU that's on the pole itself, since it's swinging or moving independently from the barge. Another thing to consider is an engineered pole or just calculating offsets. Wherever you mount this sonar, you want to be able to get good offset measurements. As we talked about earlier, the GNSS sky visibility for the GPS antennas, where you're going to mount the topside unit, and then the biggest consideration is that turbidity. You can see in the bottom right-hand side there, kind of that muddy water coming right out of the bucket right in front of where the sonar is. So, guaranteed you're not going to get a good solution there if it's silty material and suspended material is in the water column. With our testing, we pulled the survey boat along right at the bucket, and then we kept moving it down the dredge and seeing how far away it would take to not see that plume anymore. And it's really dependent on, the grain size of what you're digging and if there's any water current. So it's really dependent, but we saw a really reliable solution if you're 100 foot back from where the bucket is. And that, it could be different everywhere, but that's just what we had found. So a mounting solution is, I actually went to Japan and visited a bunch of dredges there, and what they had was moon pools, and a lot of their dredges had these sonar wells, moon pools, and these are different examples of different dredges, and these were all mounted in front of the crane, so very close to the bucket. On the left-hand side there, you can see a kind of a winch system, so they can raise up the sonar if it wasn't in use or they're transiting, and then they can store it somewhere, then redeploy it down the moon pool at a later time. Another consideration is biofouling. This picture was actually, we were in Puerto Rico, so it was warmer weather, but this is what it looked like after just 1 week in the water. And one thing you want to consider is these sonars are going to be underwater for every day for however long you're dredging for. So you might have to go with some biofouling coatings. Actually, you really should. Otherwise, this will happen. Another consideration is titanium rotator. Supposedly, they are not as susceptible to biofouling. You're going to have to clean these things. You're going to have a way, if you're mounting it on a pole or in a moon pool, a way to get it up and clean them every so often. And then you want to consider multi-beam or single beam for cleaning, because with the single beam system, since it's the transducers inside that dome, you're not, if you were to clean it off, you're not actually scratching up the transducer itself. It's just the dome around it. So you can be a little bit more aggressive with it and clean it off. But with the multi-beam, there's a lot more sensors down there, and you don't want to be messing everything up on that. So some of the advantages from single beam versus multi-beam, like I was just saying, that it's easier to clean, and the single beam is cheaper. But the downside is it takes a longer scan time, or if you have the same scan time, it'll just be a lower resolution data, and which is the advantages of the multi-beam. It has more data and faster sweeps between bucket cycles. So in order to set this up in high-pack hardware, it's basically just like setting up a multi-beam boat. The only difference is we put in the Sidus driver that will be used for the heading. This is for the R2 Sonic setup. So that's now your heading instead of the barge, or the boat or barge heading. And for Norbit, it was very similar, but their rotator's integrated with their driver, so you don't need a separate driver. You just go into their setup there, and there's a checkbox for use rotator data. So it makes it very simple. And one other thing is on the right-hand side in that driver, there's a little drop-down that couldn't get the data in for a while, but there's another menu that you have to select the Norbit system as well. For our dredge, for our application, we actually want to have two computers, two instances of HiPAC, one showing the bucket depth and one showing the sonar depth. We didn't want to rely completely on just having sonar data update the dredge in case there was turbidity or they weren't getting good data. So we already were running two computers as redundancy, and the operators have a switch that you could just toggle between what the screen in front of them, what computer they're looking at. We actually did end up installing another monitor too, so they can have the sonar data matrix update on one screen, and then on the other screen they can see the bucket view. Here's some data when we were doing our testing. You can see the red right above that number 5 there. You know, that's where we were encountering some turbidity, so that was giving us some pretty crappy data. But otherwise, we were getting some good scans. Those scans were likely due to when we were moving or shut down, greasing the bucket or changing scows. Another consideration is as the sonar is rotating, further away from the sonar, you're going to get more sparse data just because that angle is widening up out there. So one solution is you can either just scan it over and over again to fill in all those gaps, or just use a larger matrix cell size. And for dredging, I mean, you can get away with a 3x3, a 5x5 foot cell size. So that's not really too much of an issue, but just something to consider. And also to fill in those gaps too, you can use the Sidus driver that HYPACK created and just move slower. So on the top, you can see we were going at a fast speed and it was leaving the gaps between the data. But when we slowed it down, we were able to get a lot more coverage. Some of the challenges we had, as I mentioned a few times, was the turbidity, all the suspended sediments. And this is going to be dependent on water currents, the grain size. If you're digging gravel, then it's going to fall out of suspension and you won't have this issue. So that picture there is what the sonar looks like a lot of the time with how close our sonar was to the bucket. Another challenge was the bucket inside the water column. So when the bucket's dropping down to go take a bite, you're picking that up on the sonar, and it's going to have a decently strong return bouncing off the metal bucket, and it's going to think it's the real bottom, but it's not. So that's another thing. You want to do scans when the bucket is not going through the water column. And then another challenge is the sound velocity casts. With multi-beams, it's very important to get frequent sound velocities, so you kind of have to rely on your dredge crew to go out there, take sound velocity casts, and upload it to the computer, which is not the easiest for some of these dredge operators and dredge crew. So it's just something they would have to consider if you're thinking about this system. But the benefits are, aside from solving a lot of these other issues, is you can utilize this sonar data if you can't survey with the boat, if it's bad weather, or just the boat's broken down, the engines are broken down or whatever. So you can utilize this data same way you would with multi-beam data from your survey boat. You can bring it into high sweep editor and calculate volumes, produce deliverables off of that if you really wanted to. And you can also get data underneath the dredge that you might not be, if it's too shallow, can't shoot underneath the dredge with your survey boat. You can just use the multi-beam that's on the dredge. Some future improvements. For HYPACK, it would be nice for, we were talking with Jerry and hopefully we can figure out a solution to filter the beams within HYPACK to filter out all the noise from the turbidity and not update the matrix with that. And then there's also dredge mode in high sweep. This feature actually wasn't available when we were doing our demo, so I actually don't know too much about it, but Jerry's going to be talking about that tomorrow. So the final results, we ended up going with the Dredge Pack software. It was the easiest file workflow for our team. Using channel files, we don't have to create different channel files for the other softwares. We're not doing double work because we're already using channel files in our volume calculations in HYPACK Office. The color files were more customizable, and the geodesy was a lot easier setup. So it was everything that we were already used to, and didn't have to do the double work of using a different software. The multi-beam sonar, we decided to go with that just because of our scan time. The bucket is only out of the water for 30 seconds or so, so we wanted to make sure we had that quick scan time that you get with a multi-beam. And then we also decided to, on this is our, I should have mentioned this is a DB Catalina. This is our new dredge that is currently being built in the shipyard. We decided to go with 2 moon pools, one at the bow underneath the crane so we can get the most up-to-date data, applicable to where the bucket actually is. So if the bucket is spilling material out and creating high spots, we can get that data right away and be able to dredge it before we have to come back for cleanup dredging. But I decided we do kind of want another moon pool just in case that we're digging very silty material and all that, that sonar data is unusable. We want to be able to have at least data that's maybe a little bit behind, 20 minutes, 30 minutes behind, but at least the operators will see what they've been doing for the last 30 minutes, and they can make changes if they wanted. And then we also are deciding to use a barge-mounted IMU instead of integrated. Just less equipment that's underwater. It's a little bit cheaper since we didn't need to have 2 IMUs at both moon pools. And then also, if we decided we weren't going to be using the sonars, we still have the motion that we can use for the dredge itself. And I have a little disclaimer there that this is just the setup that we're going with. Everybody, if you're going to decide to put this on your barge, talk to the manufacturers and see what you like, do demos yourself, and see what works best for your operations. That's all I have. Does anybody have any questions? Yeah.
How much, time did you, say if you were using trucks to just move the dredge out of the way to survey, that versus doing the scans, how much time did you save?
You're talking about just being able to get data.
If you didn't have the system,
Yeah.
and you were using just a survey boat,
Yeah.
using this, what was the increase in production, percentage-wise?
Yeah, it didn't calculate that, and we did just have this for a week, each of these demos, but really the added benefit is with a survey boat, you have to have somebody on there all the time if you wanted to have the constant updates to the operator. So, which, yeah, I mean, I guess you could man a survey boat all the time, but this is more so you could just have consistency throughout the whole day rather than what you're saying, like moving the dredge out of the way. Yeah.
Which multi-beam system did you guys go for?
R2 Sonic is what we're going to go with. But like I said, all of them had their place and all of them had pros and cons, and really have to decide for yourself if you're going to think about it. Yep.
I think to follow up on this question, do you have statistics on how much you have to go back on normally? What is the potential upside?
Right. No, I don't, but that's, I know we spend hundreds of thousands of dollars a year going back to clean up. I have all that data to show how much time we've spent cleaning up, but I actually don't. I should calculate that. Yes?
Do you have any statistical analysis, data that you collected off of the dredge versus your base survey data after you came back from the survey vessel? Or the systems?
Like how they compared?
Correct.
For the Norbit system, we did do a side-by-side comparison, and we lined it up on cross sections, and everything looked right. The R2 Sonic, we didn't have too much time with it, and it was more so just a proof of concept rather than seeing how accurate they were between the two. Any other questions? All righty, thank you.